All right, this is part 2 of 2 on end behavior of polynomial functions. I want you to receive MATH-isfaction, become more confident with your algebra. Have 2 examples, the final 2 examples, because there are 4 total cases for end behavior of polynomial functions. D of x equals x squared minus 5x minus 1. Again, let's look at the leading coefficient of this polynomial. It is positive 1. When the leading coefficient is positive, then the right end of the polynomial graph is going up. Let's look at the h of x function. Negative x to the third plus 4. The leading coefficient is negative 1. What matters is that it's negative. The sign is negative. The right end of the polynomial function is graphed down. If you like, you can begin this down here. Okay. Now, let's look at the degree of the polynomial to determine what's happening on the left end. The degree of this polynomial, the highest exponent is 2. That's even. When you have an even degree, both ends go in the same direction. So the left end must also go up for this function, with the right end going up, and you have an even degree. For the h of x function, the degree is 3. The highest exponent is 3. That is an odd number. With an odd number, the ends go in opposite directions. The right end is going up, the right end is going down, therefore the left end is going up. Odd exponent for the degree means the ends go in opposite directions. Now, because this is an even exponent, that does not mean this is an even polynomial, and this is not necessarily an odd polynomial function. Just the highest degree is even and the highest degree is odd. Okay, let's describe these algebraically. On the right-hand side, x is approaching infinity, which is also indicated as positive infinity. The input is increasing. What's happening to the function? The output, it is also increasing. So as x approaches positive infinity, the function d of x approaches positive infinity. With the h function on the right-hand side, as we go further to the right, x approaches positive infinity. Now, with x approaching positive infinity, the input increasing, the function is going down. The output is decreasing. The function h of x is approaching negative infinity. Lastly, let's look at the left-hand side of each function. On the left-hand side, x is approaching negative infinity. You must include that negative sign for negative infinity. As x approaches negative infinity, you go further to the left, the function increases. More and more, it continues to go up, so the function d of x approaches positive infinity, or infinity. We will include the positive sign on our example here. And for the function h of x, as we go further to the left, the input x approaches negative infinity, and the function, the output values are increasing towards positive infinity. That completes our third and fourth of 4 total possibilities of what can happen with end behavior of polynomial and functions. Hope you feel more confident about the material. I hope I gave you MATH-isfaction. Bye.